Let's take a look at the work-energy principle. Now, some textbooks use the word principle and some of them refer to it as a theorem. Basically, they mean the same thing. They're just a relationship between work and energy. So far, we know that energy is the ability to do work and work is the transfer of energy. So these two terms are kind of linked with each other. We're going to start with the kinematic equation, and I'll show you how it is going to help us derive the work energy principle. We're going to do some math operations by moving around some variables. First of all, we took the u square to the other side of the equation. Then we're going to switch the two sides and rewrite this equation by putting the 2as on the left hand side and v squared minus u squared on the right hand side. Next, we are going to replace the acceleration using Newton's second law. We've already seen this relationship, so I'm going to replace the a with F net over m, the mass, and again move around some variables and change the form of this equation. What I'm going to do is I'm going to move the 2 and the m to the other side of the equation. So basically I have to do the opposite of multiply 2 by dividing it on the other side, and the divided m will be multiplied on the other side. So let's rewrite this equation. I got rid of the 2 and the m on the left hand side, and on the right hand side I got a term half m multiplied with a v squared minus u squared. Now again, I can rewrite this form as half mv squared minus half mu squared by using the distributive property. And now I recognize the Fs is the work and half mv squared is the kinetic energy. Now if you remember, for kinematics, v is the final velocity, so that should give us the final kinetic energy, and u is the initial velocity, so that should give us the initial kinetic energy. Now let's rewrite these equations. I said F net times the displacement, which is the force responsible to displace the object, gives us the work done. Half mv squared is our final kinetic energy because v is the final velocity. Half mv u squared is the initial kinetic energy. So if you put these two sides together and rewrite this equation, basically what we're saying is that work is equal to the change in the kinetic energy, because we're taking the final kinetic energy minus the initial kinetic energy. So that's defined as change in kinetic energy. Or rewrite this equation using the symbol delta for change. Now this is the basic form of work energy theorem. Sometimes we don't put the kinetic energy as a symbol and we just put it down as delta E to represent the work energy principle. Now let's take a look at this equation to help us understand what it actually means. But it's telling us that the work is equal to the change in the energy, and that's the work energy theorem that we use in physics. Now what is the work in this case? It's basically the work done on the system or to the system to change or transfer some energy, or to cause some change in the energy of the system. Now I'm using the word system. What do I mean by the word system? So system can be any object that you have in your scenario or objects. It can be a car. Let's say, take some examples. Let's say we have a car, or let's say we have a truck. Then in the scenario, those are the common examples that you will usually see in the problems. Now any of these three objects that I have listed down can be considered as a system. Now there are two types of systems that we can use to solve a problem. Either we can consider it as an open system, or we can consider it as a closed system. I'm going to just define what I mean by open system. Let's say we have a person that is pushing the car, and in this scenario you can see that there are two things involved. Or if you can consider a system where a car is being accelerated from a person sitting inside the car. So that's a closed system. Whereas the open system, we have two objects and involved in some change in the energies. All right, so we're going to apply the work energy theorem with an example. Let's say we have a car and we also have a truck are moving with the same velocity. So let's put down some numbers for the mass of the car, 1500, and mass of the truck as 2500. And let's say both are moving with the same velocity, and we're going to just take some number, let's say 5 meters per second. And they're both approaching a traffic signal, which is red light, and which means that they both have to stop. So we want to find out how much work is going to be done by the brake system of the car and the truck. I'm going to list down the variables that I know. The initial velocity for both is 5 meters per second. Since they're both coming to a stop, their final velocities are going to be equal to 0. Now these kind of questions where you have to find how much work is being done with only the information of the velocities, that's where you can apply the work energy principle. So we're going to start by writing down the work energy principle. I'm going to break it down from the change in energy as change in kinetic energy because it's moving and coming to a stop. So let's find out for the car. If I plug in all the numbers, mass is 1500 and then final velocity is 0. Initial velocity is 5 meters per second. So I'm going to square the 5. So the work done by the brake system of a car is going to be equal to, I'm going to solve these numbers in the calculator, and my final answer is coming out as negative 18,750 joules. Let's find out for the truck using the information that we were given in the problem. So in this case, we're going to apply the mass of the truck, which is 2500, and initial velocities and final velocities need to be squared in the equation. So when we solve this equation and put the numbers in the calculator, I'm getting 0 minus 31,250, which means that I'm getting a negative answer of 31,250. Now this is a bigger number for the truck, which means that the truck braking system is going to do more work as compared to the car. In other words, it also means that the trucks need to have a stronger brake system in order to apply brakes to change their velocities faster. So that's another way to look at us, understand the system. Another kind of example that I'll show you is another type of questions that are being asked often in the test. For example, how fast an object is moving, and let's say it's a block which has a mass of 2 kilograms, and we want to find out the velocity when there's a force being applied, and let's say the force applied is 10 newtons to move it through some distance or displacement, or get it displaced by 2 meters. Let's say it's moving through 2 meters of displacement, and let's consider let's say that the block is initially at rest, or it's not moving. So its initial velocity is going to be equal to 0, and using that information we can again use work energy theorem in order to find the velocities with given force and given displacement. Let me draw a picture for the scenario to help you visualize what's happening in the scenario. Initially the block is at rest, then there's a force being applied to it and it's moving to the right, let's say for example to the right, and it's moved through a displacement of 2 meters, and the question is asking to find how fast it is moving with that force of 10 newtons being applied. So let's find out the final velocity by using the work energy theorem by finding the change in kinetic energy. Now work I know is can be calculated with force times displacement times the cosine of the angle between force applied and the displacement, and change in kinetic energy is final kinetic energy minus initial kinetic energy. So let's find out the work first. We're going to think, looking at the picture, that the force is parallel to the displacement, and we can say that the angle between the force and displacement is 0, and the work done is equal to 20 joules. Now let's find out the change in kinetic energy now. Plug in the masses, mass of this block and the velocities. So final velocity is what we are looking for. I'm going to leave it in the equation as a v so that we can solve for the unknown variable. So I have 2 got cancelled, so I'm left with v squared minus 0. So I'm going to just leave it as v squared. Now work energy theorem says that these two equations that I have put a box on it should be equal, which means that 20 is equal to square root of 20. Now when we take the square root of a number, remember that there has to be 2 roots to this answer. It's either positive or negative. Now look at the equation, the scenario that I've drawn. Since the force is applied to move it to the right, and I took the force as a positive number, so I'm going to take the positive answer for the final velocity as 4.47 meters per second. Now this is because it's in the same direction in which the force is being applied.